Welcome again. This is lesson 1.5 on partial fractions, A-level, pure maths, year 2. This lesson is the last in the series on partial fractions. In this lesson, we are going to deal with improper algebraic fractions. An improper algebraic fraction, f of x, will always be given in the form p of x over q of x, where p of x is the numerator and q of x is the denominator. For f of x to be an improper algebraic fraction, the degree of p of x must be greater or equal to the degree of q of x. The splitting of f of x into partial fractions would depend on the degree of p of x and the degree of q of x. The following are some examples. In the first case, we have x squared minus 1 over x squared minus 5x plus 6. Even though, in this case, the degree of the numerator is the same as the degree of the denominator, it is still regarded as an improper fraction. In the second case, we have x cubed over x squared minus 3x plus 2. You can see that the numerator is a cubic and the denominator is a quadratic. Even though the numerator has got one term and the denominator has got 3 terms, it's still regarded as an improper algebraic fraction. In the third case, we have got a cubic and a linear, and then we've got a quartic here, x to the power 4 plus 3x minus 4 over a quadratic, x squared plus 1. You're not going to split this into partial fractions. To split this one into partial fractions, there are two methods. The first one is polynomial division, and the second one is using a formula given by f of x is equal to r of x plus a proper fraction, s of x over q of x. In this lesson, we're going to learn how to use the two methods to split improper algebraic fractions into partial fractions. So let's start with the first one, which is polynomial division. Now, polynomial division itself has got two methods. The first one is a long division method, and the second one is a grid method. So I'm going to use both in this slide, and then we'll go and learn how to use a formula in the subsequent slide. So first, the long division method. This is where we use the bar shelter. So in this case, we put the numerator under the bar shelter and the divisor outside the bar shelter. Now in this case, we just got one term for the cubic. It's advisable to include the x squared term, the x term, and the constant by appending zeros as coefficients for all of them. So we can do that and get the following. Now we are ready to do our division. First, we look at this and that, and then find what we can multiply x squared by to get x cubed, and that will be x. I then multiply x by this divisor, and I'm going to get x cubed minus 3x squared plus 2x. I'll then do my subtraction, and x cubed minus x cubed is nothing. 0 minus 3x squared is 3x squared, and 0 minus 2x is minus 2x. So I get that. I then bring down the 0, and I'll get that. Then I look at this and that, and find a number that I'll multiply x squared by to get 3x squared, and that will be plus 3. So now I multiply 3 by this divisor here, and I'm going to get 3x squared minus 9x plus 6. I then do my subtraction, and I'll get 3x squared minus 3x squared is 0. Minus 2x minus 9x means minus 2x plus 9x, and that is 7x. And 0 minus 6 is minus 6. So I get this. So at this point, there's nothing that I can multiply x squared by to get 7x. So we conclude that this is the remainder, and this is the quotient. And so we can write this fraction as follows. That will be equals to x plus 3 being the quotient plus a proper fraction here where 7x minus 6 is the remainder over the divisor, which is x squared minus 3x plus 2. In some instances, this will not be the final solution because in some cases, the denominator here or the quadratic can be factorized. But in this case, x squared minus 3x plus 2 is irreducible. That means we cannot factorize it, and that's why we leave our answer like that, and that is, on this occasion, our final answer. So let's go now and use the grid method to try to achieve the same results. So for the grid method, we are going to draw a grid like this, and then we'll proceed by putting the divisor in this column. And the divisor is x squared minus 3x plus 2. So I have x squared minus 3x and 2 over here. And the numerator, x cubed, I'll start by putting x cubed here, and I'll find what I'm going to multiply x squared by to get x cubed, and that will be x, and I'll put that one here. So I'll get x. Now I can see that x times minus 3x will be minus 3x squared, and then x times 2 will be 2x. But looking at the numerator, I don't have an x squared term that has a coefficient of minus 3x. So to undo this minus 3x squared, so I need to undo that by putting 3x squared over here. And so minus 3x squared plus 3x squared is 0, and that's exactly what we want, because this one doesn't have any x squared term, because the x squared term here is 0. So because we've got 3x squared here, I have to find what I'm going to multiply x squared by to get 3x squared. That's going to be 3, so I can put 3 here. So now I can do some more multiplication. 3 times minus 3x is minus 9x, and 3 times 2 is 6. But now you can see that for the x term, I have 2x minus 9x. 2x minus 9x is minus 7x. By looking at the numerator here, I do not have an x term that has a coefficient of minus 7. So to undo this minus 7 here, I need to put 7x over here. And that means 2x minus 9x plus 7x is 0, and that's exactly what we want, because there's no term for x over here. Similarly, looking at the constant, there's no constant here, but here I'm left with 6. To make the constant term equal to 0, I have to put minus 6 over here. Now looking at this one and that one, there's nothing that I can multiply this by to get 7x. So we stop here and conclude that the remainder is 7x minus 6. And then the quotient is x plus 3. So this will always be the quotient, and the results here will be the remainder. So now x cubed over x squared minus 3x plus 2 will be equals to x plus 3 plus the remainder, which is 7x minus 6, over the divisor. So I get the following. And that's exactly what we got using the long division method. So these are the two methods. This is the long division method, and this is the grid method. So that's polynomial division. So next we're going to look at using the formula. So the formula is given by f of x is equal to r of x plus a fraction, which is s of x over q of x. And before I proceed, there are some definitions I want you to note. The r of x is known as the quotient, s of x is the remainder, the q of x is obviously the divisor, and then the f of x is known as the dividend. Q of x will always be the denominator, and r of x will depend on the difference between the degree of the numerator and the degree of the denominator. So let's look at some examples. So first, you have a squared minus 1 over x squared minus 5x plus 6. In this case, the degree of the numerator is equal to the degree of the denominator. So the difference between these two degrees is 0. And that implies that r of x will be a constant, and f of x will be linear, because q of x, which will be this, is quadratic. And so we have the following. So that's a constant a plus a linear bx plus c over the divisor, which is q of x. A is a constant because the difference between this and that is 0, and then the degree of the x here is 0, so they must correspond. Sometimes this is a long process when the denominator can be factorized. So you need to check that. And this can be factorized as follows. X squared minus 5x plus 6 can be factorized to give x minus 2, x minus 3. So I can rewrite this as follows. So we can now go ahead and split this as follows. So now we can see that b over x minus 2 plus c over x minus 3 has replaced bx plus c over x squared minus 5x plus c. And if we use this one to find a, b, and c, that will be a shorter process than doing this and then going on to split this one further into partial fractions. So you need to check if this one can be factorized, and then you can use this process instead of that. The next one is x cubed over x squared minus 3x plus 2. So in this case, the numerator has a degree of 3 and the denominator has a degree of 1. The difference is 1. So in this case, f of x will be a linear function and s of x will be a linear function as well, because q of x, which is x squared minus 3x plus 2, is quadratic. So we get that. And you can see that the degree of the x here is 1, which corresponds with the difference between the degree here and the degree over there. So this is a linear because of the difference between the degree here and the degree here being 1. And this is linear because the denominator is quadratic. The next one, we have x cubed plus x squared minus 7 over x minus 3. The degree of the numerator is 3. The degree of the denominator is 1. The difference is 2. So in this case, r of x will be quadratic because the degree of a quadratic is 2, corresponding to the difference between the degree here and the degree here. And then, so here, the denominator is linear. So q of x in this case will be x minus 3. That means s of x will be a constant. So we have the following. So we have a quadratic term plus a constant over a linear denominator. And then finally we have, in this last case, the degree of the numerator is 4. The degree of the denominator is 2. And the difference between the degrees is 2. 4 minus 2 is 2. And that means that r of x in this case will be quadratic. And then because the denominator here is quadratic, s of x will be linear. And so we have this. And this is the process of how to split an improper algebraic fraction into mixed fractions. And then from here, you can proceed to use the principles that we've learned before to find the values of a, b, c, d, and so on. So let's now go and use these principles to solve this question. X cubed over x squared minus 3x plus 2. So first we look at the degree of the numerator and the degree of the denominator. The difference is 1. And that means that r of x, in this case, will be linear. And because q of x is quadratic, s of x will be linear as well. And so we have this. So we can now go and multiply all the three terms, this one, and that, by the denominator of the left-hand side. So if I do that, I'm going to get that. And as you can see, this will cancel that, and this will cancel that. So if I do my calculations, I'm going to end up with this. X cubed on the left-hand side, and then ax plus b times x squared minus 3x plus 2 plus cs plus d on the right-hand side. Then I'll expand the right-hand side to get the following, and then I'm going to collect like terms. If I do that, I'm going to get ax cubed, b minus 3a, x squared, which will be a combination of this and that. And then for the x term, I'll have 2a minus 3b plus c. And then for the constant terms, I have 2b and d. And then we say comparing coefficients. I can see now that the coefficient of the x cubed term on the right-hand side is a, and the coefficient of the sq term on the left-hand side is 1. That means a is equal to 1. For the x squared term, the coefficient on the right-hand side is b minus 3a, and the coefficient on the left-hand side is 0. And so we get b minus 3a is equal to 0. This means that b is equal to 2a, but I know the value of a to be 1. That means b is equal to 3. For the x term, the coefficient on the right-hand side is 2a minus 3b plus c, and the corresponding coefficient on the left-hand side is 0. So I have 2a minus 3b plus c equals to 0. This means c is equal to 2b minus 2a. But I know the values of a and b, and so if I do my substitution, I'm going to get c equals to 7. And finally, for the constant terms, on the right-hand side, I've got 2b plus d, and on the left-hand side, I've got 0. That means 2b plus d equals to 0, which implies that d is equal to minus 2b, and the value of b is 3, and that means d is equal to minus 6. And so finally, our fraction, which is x cubed over x squared minus 3x plus 2, will be equals to x plus 3 plus 7x minus 6 over x squared minus 3x plus 2, because a we got to be 1, so that's 1 here, and b we got to be 3 over here, c we got to be 7, and d we got to be minus 6. So this is how you convert improper algebraic fractions into mixed fractions using the formula. So at this point, we are going to go and solve 2 more questions involving improper algebraic fractions. So let's go and do that. So I'm going to solve these 2 questions using both the polynomial division method and then the formula. So for the first question, I'm going to use the long division method. So I've got x squared plus 0x minus 1 divided by x squared minus 5x plus 6. So x squared times what will give me x squared, and that will be 1. So now I multiply 1 by the divisor, and I'm going to get x squared minus 5x plus 6. And then I'm going to do my subtraction. And if I do that, I'm going to get 5x minus 7. And so the whole fraction now becomes x squared minus 1, all of that, over x squared minus 5x plus 6 equals to 1 plus 5x minus 7, all of that, over x squared minus 5x plus 6. But this one here, this proper fraction here, can be further split into partial fractions. So if you do that on its own, we'll have 5x minus 7 all over x minus 2 times x minus 3, because x squared minus 5x plus 6 can be factorized to get x minus 2, x minus 3. So this will be equals to a over x minus 2 plus b over x minus 3. Then I'll multiply all the 3 terms by this denominator. If I do that, I'm going to get 5x minus 7 on the left-hand side equals to a brackets x minus 3 plus b times x minus 2. Now I'll do my substitution appropriately. So when x is equals to 2, then I'll have 3 on the left-hand side, because 5 times 2 is 10. 10 minus 7 is 3 equals to, and this will be eliminated because 2 minus 2 is 0 and 0 times b will be 0. And so if I put 2 here, I'll get 2 minus 3 is minus 1. And so I have minus a, which implies that a is equals to minus 3. And when x equals to 3, on the left-hand side, I will get 8 because 3 times 5 is 15. 15 minus 7 is 8. And on the right-hand side, I will have this term eliminated. And so 3 minus 2 is 1. 1 times b is b. And so b is equals to 8. And so now I can write the whole fraction as follows. X squared minus 1 over x squared minus 5x plus 6 is equal to 1 from here minus 3 over x minus 2 plus 8 over x minus 3. And this is the final answer required for this fraction. And so this is the polynomial division method. I'm going to do the same question using the formula. For the formula method, x squared minus 1 over x squared minus 5x plus 6 can be rewritten as follows. X squared minus 1 over x minus 2 times x minus 3, because we have already factorized this denominator over here and we got that. So now this fraction can be written as x squared minus 1 over x minus 2 times x minus 3. And because the difference between the degree of the denominator and the degree of the numerator is 1, we will have a constant a plus b over x minus 2, which is this one here, plus another constant c over x minus 3. The next step is to multiply all the 4 terms, this one, this, and that, by the denominator of the left-hand side. If I do that, I'm going to get x squared minus 1 on the left-hand side equals to a times x minus 2 times x minus 3. Then x minus 2 will cancel x minus 2, and so I'll have plus b times x minus 3. And similarly, this term will reduce to c times x minus 2. Then I have to do some substitution here. So first, let x equal to 2. So when x is equal to 2, on the left-hand side, I'll have 2 squared is 4, 4 minus 1 is 3. So I have 3 on the left-hand side is equals to. Then for the right-hand side, the whole of this term will be eliminated because 2 minus 2 will be 0. And so will this term be eliminated because 2 minus 2 is 0. So I'll be left with only this term. And here, 2 minus 3 is minus 1. So I have minus b on the right-hand side. So this implies that b is equal to minus 3. So the next substitution I'm going to do is to let x equal to 3. So when x is equal to 3, on the left-hand side, I'll have 3 squared as 9. 9 minus 1 is 8. So I have 8 on the left-hand side equal to. And on the right-hand side, the whole of this term will be eliminated because 3 minus 3 is 0. So will this term be eliminated because 3 minus 3 is 0. So I'll be left with 3 minus 2, that's 1. So I get 1 times c, I'll get 8 is equal to c. So c is equal to 8. And then for the next substitution, I'll let x equal to 0. So when x equals to 0, on the left-hand side, I have 0 minus 1, that is minus 1, equals to. And on the right hand side, that would be 0 minus 2, that's minus 2, and 0 minus 3 is minus 3, and so minus 3 times minus 2 is 6, so I have 6a. Then 0 minus 3 is minus 3, so I have minus 3b. 0 minus 2 is minus 2, so I have minus 2c over here. But I know the values of b and c. So for doing my substitution, I'm going to get minus 1 is equal to 6a plus 9 minus 16. And solve it for a, I'm going to get a is equal to 1. So this implies a is equal to 1. So I've got my values for a, b, and c. I'm going to substitute them in this equation here. So I have x squared minus 1 over x squared minus 5x plus 6 is equals to a, got to be 1 over here, so that's 1, plus b, we got to be minus 3, so I have minus 3 over x minus 2, and finally c, we got to be 8 over here, and so plus 8 over x minus 3. I can write this nicely as follows. So 1 minus 3 over x minus 2 plus 8 over x minus 3. And as you can see, we got the same answer as using the polynomial division method over here. So we move on to question 2 now. So for question 2, I'm going to use the grid method for the polynomial division. So I'll draw my grid. I'm going to start by putting the divisor in this column. So I'm going to get x here and minus 3 over there. Then the numerator, I've got x cubed, so I'll start with the x cubed. So I'll put x cubed here. And that means that I have to multiply x by x squared to get x cubed. So I get x squared here. So this means that I need to put minus 3x squared here, because x squared times minus 3 will give me minus 3x squared. So I have minus 3x squared over here. But looking at the numerator, I do not have an x squared term that has a coefficient of minus 3. What I need is a coefficient of 1. So to get 1, I have to put 4x squared over here, because minus 3x squared plus 4x squared will give me x squared. And that also means that I need to put 4x here, because 4x times x will give me 4x squared. So let's put 4x here. And since this is 4x, it means that I'll need to put minus 12x here, because 4x times minus 3 will give me minus 12x. So I have minus 12x over here. Well, looking at the numerator again, I do not have an x term here which has a coefficient of minus 12. What I need is 0. So to undo this minus 12x, I put 12x here. And now I have minus 12x plus 12x gives me 0, which is what I need in the numerator, and x term which has a 0 coefficient. And this means that I need to put 12 here, because 12 times x will give me 12x. So I put 12 over there. And now 12 times minus 3 means I need to put minus 36 over here. So this will be minus 36. Then again, in the numerator, the constant term is minus 7 and not minus 36. So it means I need to undo that, and that means I'll have to put 29 over here to get a total of minus 7. So I'll put 29. There's nothing that I can multiply x by to get 29, and that means I'll stop at this point. That means 29 is my remainder. So now I can write my fraction as follows. X cubed plus x squared minus 7 over x minus 3 is equal to this term, which is x squared plus 4x plus 12 plus the remainder 29 over the divisor, which is x minus 3. And that is the required solution to this question here using the grid method. So I'll now finish this session by solving the same question using the formula. So using the formula, as we explained earlier, the degree of the numerator is 3 and the degree of the denominator is 1. And the difference is 2. So it means that x cubed plus x squared minus 7 over x minus 3 is equals to a quadratic term. So a x squared plus bx plus c plus a proper fraction, which will be a constant b, over the linear denominator x minus 3. So now I'm going to multiply each of the 3 terms, this one, that, and that, by the denominator on the left-hand side. So if I do that, I'm going to get x cubed plus x squared minus 7 on the left-hand side equal to ax squared plus bx plus c, all of that times x minus 3 plus d. So now I can expand the right-hand side, and I'm going to get x cubed plus x squared minus 7 on the left-hand side equal to ax cubed minus 3 ax squared plus bx squared minus 3bx plus cx minus 3c plus d. I'll now collect like terms, and I'm going to get x cubed plus x squared minus 7 on the left-hand side equals to ax cubed plus b minus 3a times x squared plus c minus 3b times x plus d minus 3c. Then we're going to compare coefficients. So comparing coefficients, I can see that the coefficient of the x cubed on the right-hand side is a, and the coefficient of the x cubed on the left-hand side is 1. So we can conclude that a is equals to 1. Also, the coefficient of the x squared on the right-hand side is b minus 3a, and the coefficient of the x squared on the left-hand side is 1. So we can say that b minus 3a is equals to 1. Well, I know the value of a to be 1, so that means b minus 3 is equals to 1. And this implies that b is equals to 1 plus 3, which is 4. And then the coefficient of the x on the right-hand side is c minus 3b, and the coefficient of the x on the right-hand side is 0. So c minus 3b is equals to 0, which means that c is equals to 3b. But the value of b is 4, That means C is equal to 3 times 4, which is 12. And then finally, the constant term on the right-hand side is D minus 3C. And the constant term on the left-hand side is minus 7. So we can say that D minus 3C is equals to minus 7. That means D is equals to 3C minus 7. But C is 12. So D is equals to 3 times 12 is 36 minus 7. And D is equals to 29. So now I've got all the values of A, B, C, and D. So I can just write my equation here as follows. So A we've got to be 1. So x cubed plus x squared minus 7 all over x minus 3 equals to A was 1. So I get x squared. And B is 4. So I have 4 times x, so 4x. And then C is 12. So I have plus 12. Then plus the D is 29 all over the divisor, which is x minus 3. And then we can see that we got the same answer as using the grid method for the polynomial division. And so this brings us to the end of this session on improper algebraic fractions. Thank you for watching. See you in the next video.